That's how we find the solutions of C's 3, 4, 5, and then substitute in our original series, and we get the series solution. So we can have your recursion relation. I substitute the value of C equal to 2 and take here m equal to 2. I'll get here the value of C4. Value of C4 is equal to minus 1 over m equal to 2. We get 4 into 3. Get it C4 is equal to 4. 2 into 2 is C0. Then m equal to 3. I C5 is equal to minus 1 over 5 into 4 C1. C6 is equal to minus 1 over 6 into 5 C2. C7 is equal to minus 1 upon 7 into 6 C3. C8 is equal to minus 1 upon 8 into 7 C4. C9 is equal to 1 upon 9 into 8 C5, and so on. So we can write immediately these values from the result, because we know, for example, when you have C equal to 6, this is 6, 8, then it's 8 into 7, C4. So in this way we can just formulate this one. Now here we can see we are having here, this is minus 1 over 12, C0, and this get here minus 1 over 20, C1, and this is equal to 0 because C2 is 0, this is equal to 0 because C3 is equal to 0. Then we are having this equal to C8. C8 is minus 1 over 56 into C4. C4 is here minus 1 over 12, C0. When I multiply it, I'll get here the result for this one. Multiplication is equal to 1 over 672. 1 over 672 C0. Then here we are having here minus 1 over 72 C5. I put the value of C5. The C5 is equal to minus 1 over 20 C1, and get here this 1 over 1440 C1, and so on. So we can get other values of C10, C11, C12, so on. Now I substitute these values in my series to get my solution. My series is about y equal to 0, as I mentioned here, and that we substituted because x equal to 0 is the ordinary point. So we are discussing the solution about the ordinary point, x equal to 0, and so we can write our series we were having here for y is equal to C0, C1x, C2x squared, the C3 x cubed, the C4 x4, the C5 x5, and so on. So I have the values which are 0 are C2 and C3. So I'll get here C0 plus C1x. C2 is 0 and C3 is 0. This is equal to 0 and this is equal to 0. Then we have here this is equal to plus C4 x to power 4, C6 x to power 6. Then after that, C6 is 0, C7 is 0, C4 and C5 is here, 5 not the 6, and here is 5. Then they are 0, 0. Then is C8 x to power 8, plus C9 x to power 9. Then we have a plus, so on. I substitute the value. My y is equal to, I have the value of C0, the C1x, C4. C4 is minus 1 by 12, C0, minus 1 over 12, C0 x to power 4, minus 1 over 20, C5 x to power 5. Then we are having here plus 1 over 672, C0 x to power 8. Then we are having here plus 1 over 1440 x to power 9, C1, and here also C1, and so minus, minus, plus, plus, so on. So I just define my solution as C0y1 and C1y2. I want to get two functions. We can take the value for C0 together. C0 together, we get here this equal to 1 minus x4 over 12 plus x5 over x4 over 12, yes, x8 or 672, then minus plus 1, then I take c1 common, I get here x minus x5 over 20, and get here plus x9 or 1440 minus plus 1. If I want to write this in terms of y equal to c0 y1 the c1 y2, then we can say, what's my y1? My y1 is 1 minus x to the power 4 over 12 plus x to the power 8 over 672 and minus plus 1. And then here's my y2. y2 is x, and we have a minus x to the power 5 over 20, then we have plus x to the power 9, 1440 minus plus so on. So this is my series solution, and this actually we can just stop it here also, that this is my series solution for the initial problem, for the differential equation. If we are given here the initial problem, then about x equal to 0, so we can get the value of c0 and c1 and substitute these values in our differential equation. So this was the idea, that we can apply the power series method for solving our problem. I give you 3 examples. There's some more examples given in notes. In my notes, you can just copy it from there. Also, you can get more examples from the books. You'll get the exercise in my notes also. Do practice. We can learn it by solving the problem. So inshallah, we'll continue with more. Onward, we are having the methods which are not commonly asked in the lower level differential equation course. They are going to be the higher level differential equation course. But anyway, I'm going to give you, and if you are taking these courses or your course is considering these methods, for example, we will going to discuss the solution of the differential equation about the regular singular points. As I said, we discussed the solution about the ordinary points, but we can discuss the solution about a point which is not the irregular singular, but we declassify singular point in 2 cases, regular singular point and irregular singular point. Our next discussion will be about the regular singular point.